RadMax Technologies, Inc., a wholly owned subsidiary of Regi US, Inc., is a research and development company. Our business is designing, developing, and proving axial vane-type rotary power devices for civilian, commercial, and government applications. We are focused on creating new disruptive technologies that are more efficient, compact, and cost-effective than those currently available. RadMax Technologies has designed, built, and tested 4 generations of engine, compressor, pump, and expander prototypes for multiple applications. RadMax patented technology is a family of smaller, lighter, and more energy-efficient devices designed for simplicity, efficiency, and power. The RadMax rotary principle is unique. As many as 12 straight vanes reciprocate parallel to the axis of rotation through a rotor and compress or expand fluids in the same manner as reciprocating piston devices. The rotating, reciprocating vanes follow the sinusoidal surfaces of stationary cams in the end housing, forming chambers on both sides of the rotor between the rotor, stator walls, and vanes. The chamber volume changes as the vane follows along the cam profile during the rotor's revolution, resulting in alternately compressing and/or expanding fluids at both cam locations, depending on the device's application. The desired device configuration is achieved by simply changing the cam profile and/or intake and exhaust porting locations in the cam instead of having to use complicated valve systems. Unlike piston devices, a minimum of energy is lost due to reciprocating motion and accelerations. Because the upper and lower faces of the rotor are 90 degrees out of phase and the vanes move parallel to the direction of rotation, a RadMax device is always balanced and exhibits nominal vibration. An agile technology easily modified for multiple devices, uses, and applications. The primary advantages of the RadMax technology include compact design with high output to size and weight ratios, low parts count and fewer moving parts, resulting in reduced component, assembly, and maintenance cost, increased reliability, and reduced noise. Rotary motion input and output porting does not require complicated valving systems. High internal compression, expansion, and pump ratios of up to 20:1 are possible. A combination of different function devices on a common shaft in one compact housing are possible, easily scalable from small to very large. As an engine, RadMax devices provide power through the expansion of gases, which in turn is converted to shaft torque. When configured as an internal combustion engine, combustion occurs within the device's internal combustion chamber. The hot pressurized gases cause the rotor to revolve, releasing energy through expansion as the combustion chamber increases in volume. Gas expansion can also occur in a RadMax device through gases entering from an external source. The externally sourced gas can be hot and pressurized like that used in a turbine application, or cooler and lower in pressure as in low-pressure steam. In either case, the RadMax gas expander is able to extract pressure energy. A RadMax internal combustion engine can be designed as a diesel engine or spark ignition engine, which burns gasoline, natural gas, or other similar fuels. Various prototype RadMax engines for both diesel and spark ignition configurations have been built ranging from 10 to over 300 horsepower. Like a 4-stroke piston engine, the RadMax rotary internal combustion engine also uses the 4-stroke principle. However, in the RadMax engine, the combustion chambers form between the rotor, outer housing walls, and vanes, and their volumes change as the vanes move during rotation. Because the RadMax design can have up to 12 vanes, the engine generates an incredible 24 power strokes per rotation, 12 on the upper side of the rotor and 12 on the lower side. Due to this efficient design, a RadMax internal combustion engine will produce 4 times the horsepower per revolution compared to an equivalent displacement 4-cycle piston engine. The RadMax engine utilizes passive ports rather than mechanically operated valves. Unlike the Wankel engine, RadMax technology accomplishes chamber sealing using axial vane motion rather than eccentric rotor motion. In addition to its compact size and high power, the RadMax internal combustion engine has the inherent capability to incorporate different and separate compression and expansion ratios. This translates into better fuel efficiency by getting more energy out of the burnt fuel. The RadMax internal combustion engine can also support on-the-fly variable compression, giving it a true multi-fuel capability. Providing continual, smooth rotary motion and being easily scalable, the RadMax internal combustion engine has fewer moving parts and a low part count of less than 75 discrete part numbers versus over 1,000 for a typical piston engine. This results in reduced assembly and maintenance cost, increased reliability, and reduced noise levels. The RadMax external combustion engine is a low-pressure Brayton cycle engine that uses a gas expander rather than a traditional turbine. This engine incorporates RadMax's higher efficiency and lower-cost positive displacement compressor and gas expander, along with an external combustor optimized for minimum emissions. A true multi-fuel type engine, it is a new approach in bringing lower cost and reduced emissions to power generation and automotive applications. The positive displacement RadMax gas expander is able to capture and convert both kinetic and pressure volume energy to shaft torque, which can be used for propulsion or for other types of useful work such as gas compression or electricity generation. A combination of 4 distinct sections, 2 intake and discharge cycles on each cam. This unique design allows for each of these sections to be configured with different expansion ratios for multi-stage expansion in one device. Capable of providing high work efficiency with low density and lower volume gas flows at lower speeds, it is easily scalable from small to very large devices. As a prime mover in standalone or turbine engine configurations, the RadMax gas expander is well suited for power generation, waste heat recovery, air conditioning, and natural gas system throttling and loss recovery applications. The RadMax positive displacement compressor incorporates the advantages of both positive displacement and centrifugal compressors by utilizing the volumetric energy of a positive displacement compressor and the kinetic energy of a centrifugal compressor to pressurize a gas. This results in an exceptionally energy-efficient device. The RadMax compressor design is a combination of 4 distinct sections, consisting of 2 complete intake and exhaust compression cycles on each cam. This unique design allows for each of these sections to be configured with different compression ratios, or for achieving multi-stage compression in one device by porting section output into and between the different sections. Able to efficiently compress low-density gases, its high volume output to size ratio makes it a compact and lightweight unit compared to other positive displacement compressors. Scalable from small to very large, the RadMax positive displacement compressor is well suited for compressing both high and low density refrigerants and other gases, industrial gas compression, specialty compressors for the oil and gas industry, low density gas to high pressure, and as an integral component of the RadMax external combustion engine. The RadMax pump pairs the high volume capacity of a positive displacement pump with the simplicity and cost advantages of a centrifugal pump. Able to utilize volumetric displacement energy of the fluid and the kinetic energy of the vane action, this results in an extraordinarily energy-efficient pump. Additionally, its cost to manufacture and maintain are closer to that of a centrifugal pump than that of a positive displacement pump. Together, this makes a RadMax pump a highly efficient and cost-effective solution for many pumping applications. Self-priming and easily scalable from small to very large devices, the RadMax pump is well suited for fire protection, water and flood control, irrigation, marine, water treatment, oil and gas industry downhole and subsea, industrial processes, heavy industry and construction, and portable pump applications. A truly unique capability of RadMax technology design is the ability to combine more than one machine function into a single RadMax device. The RadMax mechanism is comprised of two cams, connected by a common drive shaft in a single housing. By using separate vane actuator systems, it is possible to have two separately functioning cam cycles. For example, an engine, pump, compressor, or gas expander in the same device. The resulting compact device provides increased flexible functionality and high performance in a smaller footprint than two separate devices. These characteristics make RadMax combined cycle devices well suited for applications with weight restrictions and limited space, such as the RadMax external combustion engine, auxiliary and backup power generation, waste heat recovery, portable pumps, compressors and generators, and gas system throttling loss recovery. Because of its unique rotary design, it is possible to design electricity generation components directly into and as part of the RadMax device, thus eliminating the need and space for a separate generator. Incorporating an integrated generator into RadMax engines and gas expanders allows for the option to utilize all of the device's power to generate electricity, or use some or all of it to power other devices through its crankshaft. Combining electric generation with the RadMax device's compact size and weight make it attractive for such things as hybrid vehicles, telecommunications backup power, truck auxiliary power units, military field power generation, home backup and portable power generation, and emergency rescue and first responder applications. RadMax technology has many applications in the transportation, oil and gas, air conditioning and power generation industries. It can be utilized in internal and external combustion engines for automotive, aviation, marine, hybrid cars and trucks, natural gas and air conditioning throttling energy loss recovery valves, refrigerant compression, waste heat recovery, and backup and auxiliary power units. All of these are important and large global markets for this technology. RadMax Technologies is currently developing several proof-of-concept prototypes in these areas: truck auxiliary power unit, AC expander valve, telecom backup power unit, compression and spark ignition engines. Come join us in bringing this revolutionary new technology to the marketplace. RadMax Technologies is seeking innovative co-development partners, licensees, and customers who are interested in adopting and further developing our technology. We will be happy to work with you in developing a custom RadMax device specific to your application for evaluation and testing. Please contact us for additional information.